All right, so this is systems of linear inequalities. And so the first couple of problems are nice little problems for practice on. And so we're gonna do this. I'm gonna do them in different colors. All right, so we're supposed to graph this, and don't forget the number that's being added or subtracted to the x, that's my y-intercept. That's our starting point. And so this is where I started. So this is where we start. So I'm gonna put a dot where y is positive 2. All right, the number on the x, that is my slope, and we've been using rise over run. So remember, if it's positive, we go up. If it's negative, we go down. If it's positive, we go to the right. If it's negative, we go to the left. All right, and so that's what we're gonna do. So it's a 3. So I got to think of as a fraction, so 3 over 1. So we rise 3, we go to the right 1. So I rise 3, 1, 2, 3, to the right 1. Now I could reverse it. It's the opposite too. So this is a positive, that's positive. So I'll make them both negative. So that means I go down 3, 1, 2, 3, to the left 1. And you can see all my dots are in some sort of line. Now you got to look at the inequality. The inequality has the equal to sign. It looks like a bar. It's really hard to see on this one, but it's right there. All right. So whenever there's a bar, all right, it's a solid line. If there's no bar, no equal to, then it's a dash line. All right. So we know that this is as a bar, so it's a solid line. So I'm going to draw a solid line. Oh boy, I misdrew that. I'm going to have to use a ruler. All right, so there's my solid line. I'm off, but there's my solid line. All right, now you got to shade. Whenever you have an inequality, you have more than one answer. When it's an equal sign, you have one, but on an inequality, you have more than one. All right. And so now remember this: if it's a greater than sign, if it's like y is greater, we shade above the line. If it's a less than symbol, we shade below the line. This one is a greater than sign. See how y is greater? So we're going to shade above this line. Well, it's terrible. Pretty picky, but I mean, that's about all I can do because of the way I drew it. Okay, so there we go. So let's try this one. This one has my starting point at -2, so that's my y-intercept. So I'm going to put a dot at -2. My slope is just looks like a negative x. Well, remember, a negative x is really a negative 1x, because how many x's do you see? I see 1. So it's a -1. So then my slope, I'll make it look like a fraction, is my slope's -1 over 1. That means I'm going to go down 1 and to the right 1. Now I could reverse it. I could say 1 and -1. I'd go up and to the left. So I'm going to do both. So I'm going to start with this one. I'm going to go down 1 and to the right, down 1 to the right. This one is up 1 to the left, up 1 to the left. All right. I got a book to use for a ruler. Oh, I didn't check. Is that a solid or a dashed line? Well, it's equal to, so it's because it's an equal to, I'm going to have a solid line. That's one thing you got to watch out for, is because people are so used to drawing just connecting the dots in straight lines that we don't really look to see if it's a dash line. And sometimes it is. All right, so that's a solid line. That's a much better line, isn't it? Okay, so now I got to determine, am I shading above or below the line? Well, it says y is less than. See the less than symbol? So we shade below the line. All right. Both these questions says, where on the graph are the solutions to the inequality? Well, this one, it's shaded area. It's above the line. This one's the shaded area below the line. All right. Now this one is what we're doing. So you see what we did is we did one and then we did another. Those are both, just simple inequalities. But now we're going to use the same two and we're going to put them together. So what it is, the systems means there's two equations with two variables. And so you can see we have this. All right. So what I'm going to do is I'm going to graph these, and I'll graph them in different colors. All right. These are the exact same problems that are up here. Same ones. All right. So I'm going to go up 2. I start at 2. I'm going to take this And we're going to apply this. Okay, so this is, I use the wrong color, use the other color. So this is a +2, so it's right here. So my rise over run is 3-1. So I go up 3, 1, 2, 3 over 1. All right, it's a solid line. Oh boy, I better draw it with this. No, I'm gonna go down 3, 1, 2, 3 over 1. I like to get it 3 dots. All right, so there's my line. Looks a lot better than I did on the first one. And remember, we shade up because it's a greater than. All right, we're gonna use a different color. I like using the different colors on these. All right, so the next one is -2. So I'll put a dot at -2. And then my rise or run is up 1, up 1, to the left 1, because it's a -1, right? So it's over 1, or I could go down 1 to the right 1. So there's that. It is also a solid line. This is just like what we did up here. So we're going to connect our dots here. I'm using my book that I'm reading. No, I missed it anyway. All right, so there it is. And then I'm shading downward. Okay, if you notice, there is the two lines, the two colors are combining. See where the two lines are coloring? Now, the red or the mauve or pink, whatever you're going to call it, that's for the top line. The blue is for the bottom, but where the two meet, that's where it's good for both. So we talk about true statements. So in the shaded area, that's the true statement. That means any point that we pick, any point, even the ones up here, any point that's on this side of the line, I can put in for the X and Y values and it will work. This side will always be greater than this side. Same thing here. I pick any point, even on the line that I drew, because it's a solid line, any point, even down here, any point that I pick, I use the X and Y values for that. And this side will be always smaller than this side. The false side, that's this side here. If the false side is picked, then it will never work. This side will be bigger than this side and not smaller. Same thing over here, this false side. So this here is the false side for both. This here is only true for the one statement, and this is only true for that one. But here where the two colors combine, that is our solution. So this here, and I'm going to try to do it in a different color. We'll do it, here's black one. This area here is our true side for both of them. Not one, but both. So I can pick any point, even the ones that are on the line, because these lines are solid. I can pick any point. Remember, this continues to go out here because these lines go on forever. So even points down here, all right, I can pick the X and Y, put them in for both of them, and both of them will be true. Okay, so we're going to put it here where the graph solution systems in the double shaded area. All right, so it's in the double shaded area. Okay, so here we go. This one right here, we are going to, this is just a little phrase thing, a little word bank. Here's the word banks here. It says the solution of a system of linear inequalities are the ordered pairs of ordered pairs are solutions to all inequalities in the system. On a graph, the solution to a system of equality is the intersection of interplanes that overlap. All right, that's how that works. Okay, so let's go to the next page. All right, so we're gonna look at this one. All right, so we're gonna take one of these and do this one. All right, so same thing as before. We're gonna take the top one. All right, my starting point is gonna be the number that's added or subtracted to X. It's a 2, so where there's Y is 2, I'm gonna put red dot there. My rise over run, this is my rise, this is my run. They're both positive, so I'm gonna go up 1 over 2, up 1 over 2. All right, it's a solid line because my line, there's an equal to underneath it. So I'm gonna draw my line here. I just like to get a better drawing. All right, there it is. And I'm shading above because it's a greater than symbol. So I'm shading above the line. All right, You did good on that one. All right, now look at the next one. It says x is greater than -2. Notice there's no y. All right, remember, whenever you see, and this is a very nice tip if you haven't caught on to this, I said in class, if you look at every equation, if it has an x and y in it, then it touches the x and y axis. See, here's an x axis, here's a y axis. It touches it. See the x and y? So if I draw it, look, it touches the x axis here, touches the y axis here. If it's missing a letter, it doesn't touch that axis. So if you look, this one doesn't touch the y axis. It only touches the x. So I need to draw, I got to put a dot where x is -2. So x is -2. Here's my x, -2 is right here. All right, and I have to draw my line where it does not touch the y-axis. I can't draw it diagonally. I can't draw it this way because if I draw it this way, I'm touching the y-axis. So the only way I can draw it is up and down. Now notice something. It doesn't have a bar. So if it doesn't have a bar, it's a dashed line. That means we cannot include any point on this line. We got to pick a number greater than -2. Well, remember on the number line, if you go to the right, everything's bigger. So this is my greater side. Now, if you look, you see where the two lines intersect. They intersect right here, or two colors intersect right there. That's how you do it. All right. So remember, like in this case, see how there's a y but no x? That means we plot the point on the y, but we draw the line where it does not touch the x-axis. Okay, so there's that one. I'd like to do one that's in standard form, like these guys here. All right, so I'd like to do one. I'm gonna do number 12 because it's gotten some room over here. I'm gonna use this right here as in a guide. All right, so we got to put these like in the y equals mx plus b format. Okay, even though we're not using equal sign, we still have to put in that form. All right, so I'm going to do this one first. All right, here we go. X minus 3y is greater than -6. I can draw it right at number 6. All right, so the first thing we do is always move x because we want to get the y by itself. That's a positive. Now remember that negative is with the 3y. This is a positive x, so I'm going to subtract negative x to both sides. X minus x is 0 pair. Bring down, remember this negative is with the 3, so you got to bring -3y. -6 and a negative x. I can't combine them. I just put them together like that. My y is being multiplied by -3. So the opposite of multiply is divide by -3. So I'm dividing everything by -3. Now this is crucial. A -3 divided by -3 is a 1 whole, and 1 times y is y. Now, whenever you multiply or divide a negative, and you can tell right off the bat by looking at it, see there's a negative with the y here, negative with this y here, you flip the inequality. So instead of that way, we're going to flip it, and it's going to go this way now. Two negatives make a positive. I'll put a little positive there so you can see it. 3 goes into 6 2 times. Two negatives again make a positive. Now remember, there's one x here. That's a 1. So if you look at it, it looks like a fraction. So it's 1/3 x. All right, so there's my first one. Right there. Let's do the next one. It's the same process. Subtract 4x to both sides. We always get rid of the x first. Bring down my next one. See how it's got a -3y to it? -3. So we're going to be flipping it. Just write this down. You're not going to combine this. This is not -1x. It's not 7x. It's just 3 minus 4x. Divide both sides by -3, which again is going to make, because we're dividing by a negative number, we're going to flip our inequality. So we're going to take this, it's going to be y. We're going to flip it. So we flip that. One negative, so it makes a -1. Two negatives make a positive, and it's 4/3 x. All right, now I'm going to graph them. I'll do this one first in blue. I'll put a little mark here. Okay, so I'm going to start at 2. My rise over run, so I'm going to go up 1 since they're both positive, up and to the right. Up and to the right, 1, 2, 3. Now, since they're both positive, I could use two negatives. I can make this -1 and -3. So I go down 1 to the left 3. Is it a solid or a dashed line? Well, hopefully you'd be able to tell that it is a dashed line. And the reason why is because there's no bar underneath here. Can you see no bar? No equal to. So I'm just going to do it this way. And it's a dashed line. Not perfect, but it'll work. Okay, am I shading above or below? Looks like it says less than, so that means I'm shading below. All right, there's that one. So the next one. This is at -1. See, this is being added, subtracted the x. That's being multiplied. So this, since this guy's all by itself, it's -1. So I'll put a dot at -1. My rise or run is positive and a positive. So I'm going to go up 4. 1, 2, 3, 4 over 3. 1, 2, 3. I can go in the opposite direction. 1, 2, 3, 4. 1, 2, 3. Now, is my line dash or solid? Looks like it's a solid line. So I'm going to connect the two. It's less than. So that's less than. So that means I'm going to draw my line. So that means go below the line. And you can see it does not include this area here because this is not double color. This overlaps right here. So this right here is my overlapping. And so that right there is my answer.